Okay, so hopefully you just got done working with some of the data that we had and seeing the shape and seeing the effect that different by multiplying data or adding or subtracting what you can do to the spread of the data or the center of the data or the shape of the data, or if you can create more outliers. So working through all that SOC stuff. Well, now we're going to talk about density curves. And so we really haven't talked about density curves before, so it's kind of interesting discussion. I don't have many problems for this because it's more of an idea, and I thought talking through the idea is probably the most helpful. So here's what a density curve is, as the book defines, and it's probably a pretty good definition. One thing is it's always positive, like it's always above the horizontal axis. So if you're thinking about a number line or if you're graphing something, you can't have a density curve down here because you really can't have a negative area, and that's why they want it always. Let me choose a different color, but they'd want it always like that would be a bad density curve. This would be a good density curve because it's above. Hooray! So good density curve, bad density curve. Other thing that's helpful, it's exactly 1 underneath here. Like this area has to be 1. And if you think about why they'd want to choose 1 as their area, it's because this would then kind of work nicely to be 100%. And so that's what they're really going for, is like you're hopefully having 100% of the information underneath it. So it has to be exactly 1. It has to be positive. And so you can use this to describe different patterns, and we're gonna use this. You've already seen some density curves. This is a type of density curve, having 1 underneath it. This would be symmetric. And again, you can kind of like think about how we would have like histograms that would look like this and fit underneath the area. Probably not perfectly. There'd be like little gaps in here, but we're okay with that. And then other distributions kind of like this. And again, we would know that this is right skewed. We can see that the mean is bigger than the median. So that's what a density like distribution looks like. This is a type of problem we might get. And this is talking about a uniform distribution, and we'll talk more about the different types of distributions. But if I was like given this problem, I have an A, B, and C, and I would say A, explain why this curve satisfies the 2 requirements. Well, requirement 1, it's above. Check. Requirement 2, it's exactly 1. And you can see this because it has a length of 1 and a height of 1, and 1 times 1 is 1, so the area inside of here is 1. So that solves part A. Part B. What percent is above 0.8? So 0.8 would be over here. If we kind of drew that in, it's a height of 1. Be this area in here. Hopefully you'd go, okay, so that's going to be about 0.2. Because like 0.2 would be the length times 1, which is the height. So 0.2 or 20% of the area. This is why uniform curves are nice. And then if you did what percent is between 0.25 and 0.75, well again, if we went to the bottom here, 0.25 being somewhere in here, 0.75 somewhere in here, you should have 50% or 0.5 across. So that's how far it is across here, and a height of 1, and 1 times 0.5 will give you 0.5 or 50% of the data. So that's kind of how we use density curves. We kind of use it to figure out like the percentage in a certain area. So make sure you try the problems on the homework, and good luck on that stuff.